All right, you guys, this is the last part of the circles review for geometry final. So find the measure of arc dt and the measure of angle drt. Okay, so if this angle is 52, it's an inscribed angle. It's half of this arc right there. So double 52, that'll tell us what that arc is, so 104. Okay, and DRT is this guy right there. It's also an inscribed angle, and it's also half of this arc out here, so it's going to be 52. The theorem goes like this. Inscribed angles that intercept the same arc are congruent to each other, so they're both 52. All right, so here we go. Let's go ahead and put in angle I is 92, so let's put a 92 in right there. There's a few ways to do this. I forgot which way I did this. Okay, so that inscribed angle tells me that that intercepted arc is double that, 184. So is it a semicircle? I'm going to say no, because it has to be 180. All right, so let's put in the 124 right there, and so that 124 gives us this inscribed angle. So half of that's going to give us 62 right there. So angle S is 62. All right, now there's a couple of ways to get this one right here. I forgot what I did. Well, one way what we could do is for SIL, since we know that this is 184, we can take 184 off of the whole circle of 360. So this would be the rest of 360 right there. That's what would be SIL right there, and I think that's 176. I don't think I did it that way. I think I did my triangle as 180, and so I found out this angle was 26. So I doubled it to get this arc right here. So this arc right here is 52. All right, so that's what this is right there, and then I went ahead and did the arc addition postulate and added those together to get 176. So there's a couple ways to do that, and then find angle L. Well, angle L is that 26 that we did right there. Okay, all right, and there's several ways you can do that correctly. Okay, all right, so here we have a quad inscribed in a circle. When it's a quad, then these angles are supplementary, and so are those angles. They're supplementary. So add them up to 180, and then somewhere I made a mistake, so I either this one I put the wrong number here and the wrong number here. So given these numbers, that would be the answer for y. Okay, and so x is 15 on that. Okay, all right, so angles that are inside a circle, we add these intercepted arcs and take half of it. Angles that are outside a circle, we subtract these intercepted arcs and take half of it. Okay, so let's find x and y. Okay, all right, this is an inscribed angle. When the vertex is on the circle, it's half of that arc, so it's going to be 114. Okay, and then we can use the straight line to get y. Straight lines are 180, so y has to be 66. All right, let's get x here first. We're going to add those arcs and take half of it, so I get 76, and then we got a straight line right there, so straight lines are always 180, so we take off 76 and we get 104. All right, it's just before school, so kids are coming to school. All right, so here, let's see. On this one here, I'm going to find x first because we got a whole circle and we got most of it, so we'll just take the rest of it from 360 to get x. So we get x to be 44, so let's put that in there. And then y is outside, so we subtract these arcs and take half, and we get 16. Okay, all right, so here, let's get, oops, I showed you the answer there first here. Sorry, I forgot, I haven't fixed that yet. So this is the problem right here. Okay, let's get x first. So this angle is half of x minus 44. So 30 equals half of x minus 44. So we find out x is 104, and then y, let's see, so once we get x to be 104, then we got the whole circle for 360, so we just take the rest of it from 360 and we get y to be 107 right there. All right, okay, so here, intersecting chords theorem says piece times piece equals piece times piece. This times this equals this times this, x equals 5. Okay, this one, same thing, piece times piece, so this piece times this piece equals this piece times this piece, and so we get a quadratic equation. Quadratic equations, we want it to equal 0, so 4x squared minus 3x squared is 1x squared, and subtract 3x. We want it to equal 0 so we can factor it. So once we factor it, we set those factors equal to 0, and we get x equals 3, because x can't be 0 when we're talking about length. Okay, all right, here we do outer times whole equals outer times whole. The whole on top is 3 plus x. The whole on bottom is 4 plus 2. That's where 6 came from. Okay, so distribute the 3 through, and then subtract 9 and divide by 3. We get x equals 5. Okay, outer times whole equals tangent segment squared. Okay, so subtract 25 and divide by 5. You get 24/5. All right, so the standard equation of a circle that has center HK is x minus h squared plus y minus k squared equals your radius squared. So write an equation in standard form of each circle. So this has center here is HK and radius 5. So it's x minus a minus 2 squared plus y minus 3 squared equals 5 squared. So clean it up, you get that for an answer. Okay, here's the next one. All right, so it's x minus 0 squared plus y minus a minus 9 squared equals this radius squared. All right, so when you're squaring this, you got to square 2, which is 4, and square the radical, which is 3. So root 3 squared is plain old 3, so 4 times 3 is 12. So when I square that, that gets me 12. And we don't need to have the 0 there, so there's our equation right there. Okay, lastly, let's graph this guy. Okay, so the center is at HK. I like to think opposite opposite. So if that's a minus 1, then it's positive 1. If that's a minus 2, it's positive 2. The radius is the square root of that, okay? All right, so go over 1, up 2, and then just make some boundaries, you guys. Go up 3, down 3, to the left 3, to the right 3, because that's what the radius is, okay? And then that's your boundary, and then graph your circle. There you go. All right, if you're in my class, that is due the next day of school. All right, take care.